Hello, welcome to the Chemistry Made Sense series. In the previous videos, we learned why chemists use the mole and how the mole serves as a bridge between the microscopic world and the macroscopic world. Now it's time to use the mole to solve chemistry problems. Before we get started, let's take a look at the big picture. In chemistry, there are three important quantities that we often convert back and forth: particles, moles, and mass. Particles represent the microscopic world, including atoms, ions, and molecules. Mass, measured in grams, represents the macroscopic world that we can see, weigh, and work with in the laboratory. The mole sits right in the middle and connects these two worlds. Let's first look at the conversion between mass and moles. Mass and moles can be converted back and forth based on the molar mass conversion factor. To convert moles into mass, we multiply the moles by the molar mass conversion factor with molar mass in the numerator and 1 mole in the denominator. So we can cancel out moles to end up with mass in grams. On the other hand, to convert mass into moles, we use the reciprocal conversion factor with 1 mole as the numerator and the molar mass as the denominator. So we can cancel out the grams to end up with moles. Now, let's look at the conversion between particles and moles. Particles and moles can be converted back and forth based on Avogadro's number conversion factor. To convert moles into particles, we multiply moles by Avogadro's number conversion factor with 6.02 times 10 to the 23rd particles in the numerator and 1 mole in the denominator. We can cancel out moles to end up with the number of the particles. On the other hand, to convert particles to moles, we use the reciprocal conversion factor with 1 mole as the numerator, 6.02 times 10 to the 23rd particles as the denominator. So we can cancel out particles to end up with the moles. Remember the strategy from our dimensional analysis series. The odd unit in the conversion factor must be placed opposite to its location in the original value. This means all the mole calculations are simply applications of dimensional analysis with new conversion factors. We focus on the units, allow the units to guide us, and choose the correct conversion factors. In the next several videos, we're going to practice mole calculations from a basic to advanced levels. Thank you for watching. Please follow Chem Excel for chemistry that really makes sense.